I'm Raimus Khalil, and this is my Lab 4 on oscillations. Here's a quick table of contents. The purpose of this lab is to observe a spring mass system and compare it to its predicted motion, which is calculated in GlowScript. In our experiment, we found that our models are actually really accurate, and the fundamental physics principles that we're applying are Newton's second law and the energy principle. Newton's second law, the force of an object is equal to its mass times its acceleration. Basically just means more massive objects require more force to move. The energy principle, the system's change in energy is the sum of the work done by the surroundings and the thermal energy exchange with the surroundings, which is delta E cis equals W surroundings plus Q. In our experiment, we didn't do the experiment, we just got it from the video, but he just swings a little metal object around an undulating spring. The system is the metal object, the surroundings are gravity and air resistance, and probably the spring too. For tracking the position, we use tracker. Our predicted positions were calculated using GlowScript. So here's our initial conditions for the GlowScript simulation. We have the ball dot mass set to 0.4. We have its position at negative 0.1, its y position at negative 0.6, no initial velocity, gravity 9.8, spring constant 6.83, and the relaxed length of the spring is 0.123. Here's our actual GlowScript code where we calculate the different energies and then run it through the calculation loop. And here is the results. You can see a sine wave formation on the graph. You can see X position versus time, Y position versus time. The Y position looks a little weird. I think that's just because there was some offset that I didn't really calibrate properly. That can go in our margin of error, which goes into our tracker. That's why these graphs look so weird. I must have did something wrong, but if I were to do it again, I'd correct that. Discussion questions. Is the energy principle satisfied? Yes. The kinetic energy is oscillating and the sum of all energies is zero. The change in spring potential and gravitational potential are opposites, which coincides with the energy principle. For the other discussion question, we compared the average oscillation in trackers. So we have 2.089 seconds, 1.994 seconds. These theoretically should be the same time, but there's some differences, possibly because of air resistance or drag, whatever you want to call it. And in conclusion, our hypothesis is supported. We can accurately predict the motion of the undulating object on the spring.